BSides Cincinnati 2016 is sponsored by GE Aviation, Ashland, CBTS, Encore Technologies, Morphic. Join the conversation. Tweet us at BSidesCincy. The stream will begin shortly. BSides Cincinnati 2016 is sponsored by GE Aviation, Ashland, CBTS, Encore Technologies, Morphic. Join the conversation. Tweet us at BSidesCincy. The stream will begin shortly. BSides Cincinnati 2016 is sponsored by GE Aviation, Ashland, CBTS, Encore Technologies, Morphic. Join the conversation. Tweet us at BSidesCincy.
Okay. All right, everyone. So next up, we're going to do Scott Roberts. He visits us from the faraway land of Columbus, but he's going to talk to you right now.
Okay. I get the ever exciting right after lunch coma spot, which is far and away the best. So I'm going to ask a lot of questions where I'm going to ask you to raise your hand and just get your opinion, and that's mostly just to make sure you're awake. So cool? Cool. All right. So this is Hipster, Digital Forensics and Incident Response on OS X. In the program it mentions iOS, and then I realized that's way too much to talk about. So we're just going to do OS X, okay? Obligatory who I am slide. I've been at GitHub since 2012. I've been doing DFIR since 2006. A Mac user since '89. I was 6 then, by the way. And just doing things since 1983. To make sure I have my cred, this was my first computer, Apple II LE-C? CE? I can't remember exactly. Green screen, the whole cathode thing, it was great. Where is it right now? I assume on the bottom of if I would have known it was going to be worth something, I probably would have held on to it. But I was 9 and not very perceptive at the time, so I missed that. You should trust me, because I've done some relatively smart things with some very smart people. And now I work at GitHub. Has anybody heard of GitHub? This is that hand-raising thing, okay. What do? We're a sticker and t-shirt company. I have some stickers later, yeah, it's great. We're getting, product announcement, we're getting into Git hosting. I think it's gonna be big. Just so you know. And this is Hipster Forensics, and I want you to know, no hipsters were harmed in the making of this presentation. Oh. But there's going to be plenty of hipsters to laugh at, it's fine. So, hipster car for our roadmap. We're going to talk about some of the problems that I was dealing with running a mostly OS X environment. We're going to talk about some core OS X concepts you need, because it turns out it's not Windows, except when it is. And it's not Linux, except when it is. We're going to talk about a bunch of different tools, some of which are built in, some of which just do a lot of general purpose things. We're going to talk about free security tools, we're going to talk paid security tools, and then we're going to talk about places you can go learn way more about OS X incident response than I can put into, this is a 4.5-hour presentation? All right, so getting started. First question is, why bother? We all know Macs are just secure right out of the thing. You have this button, right? Turns out, no. There have been some problems. when the CIA doesn't like you, you've got a whole other set of issues, or just even basic developer forums. But the fact is that as market share for OS X has gone up, so have people attacking it. There was the presentation discussing 16% market share is essentially where the break-even point is for a platform being worth targeting. We're not quite to 16% with OS X, but I think it's become a big enough target that there are both commodity and persistent attack groups that are interested in attacking OS X. Unfortunately, the biggest group that hasn't caught up to that has been vendors, because it turns out most security tooling support for OS X is not great. I remember talking to one vendor and they said, "Oh, we support OS X." And I said, "Great, like what can you do?" And they said, "Well, we support the HFS file system." Not the same thing. So, this provides a problem to someone like me. And I do say on OS X, and that kind of means two things to me. There's doing incident response using OS X as your response platform, which I do. And there's on OS X as in you're responding to attacks against OS X-based machines, which I also do. So we're going to kind of bounce back and forth between those two ideas, but most things should be fairly transferable. And so to give you a little bit of perspective to my exact problem set, I need to tell you a little bit about GitHub. So we had three really, not problems. We had three challenges. We had a location challenge, we had a platform challenge, and we have an attitude challenge in how we do security at GitHub. So we have a 500-person company, and this is our distribution across the world as of last night. I don't know if there are anybody who has a smaller company with more geographic distribution. I'd like to buy you a drink later. But this provides a huge set of issues. I was used to doing incident response where we could walk down the street to grab a machine that had a problem. And being able to do this at this level of distribution without spending a fortune on airline tickets is tough. So our challenge is the fact that we couldn't be hands-on. In a lot of cases, when we want to do anything technical, it has to be driven by the user themselves. We've got to either get them to enter the command or run the right thing or simply do what we need, because we can't be there and often can't even get a technical person to do that themselves. So then there's our platform. At GitHub, I had 100%, and I realize I'm technically a little off. We've got about 3 people running Linux on the desktop. 2016 really is the year of Linux on the desktop, right? Yeah, that was, no. We have a few people doing other things, but for the most part, every one of GitHub's 500 or so employees is running OS X. At the same time, our platform in the data center is 100% Linux, which just in both cases means limited tools. I was talking at lunch with some fellows about the fact that I miss Active Directory. It turns out for doing incident response, Active Directory is super nice. You can do all kinds of stuff that we just don't have as an option. And lastly, we have our attitude. And this is kind of a Silicon Valley startup-y sort of approach. But we care a lot about trust, openness, and transparency. I have to work with my users. I can't dictate to them. We have a set of developers. It turns out if developers don't like something you're doing, they'll build a tool to mess with you. And there's nothing like when the malware is written by the people you're actively trying to protect. So, as a result, we give our users a lot of freedom, and we have to make sure that anything we build is going to support that idea. So, no draconian tactics. We can't enforce things. We can't, hammer, you have to do this. We have to make the case and get people to understand why it's important, what it's trying to do, and that it's in their best interest. And being that we're GitHub, we also really like open source stuff. We have commercial tools. We'll pay for commercial tools, but for the most part, all things being the same, we tend to go with open source. And in a lot of cases, there aren't even closed source things that would do necessarily what we need. So that's kind of the why. So let's start with concepts, and these are just important things you're going to run across. who has OSX personally, like at home? I mean, I could raise my hand for like 4 people, so. How about anybody who has OSX in their environment they work in? Okay, a few more. Who feels confident they are 100% protecting those OSX systems? I shouldn't have that up. Okay, we're all in the same boat. This is great. So core concepts and things you're going to run across on OSX. First thing you're going to run across is next and NS a lot. NS everything. NS stands for next step. It was the name of the company that Steve Jobs ran after he left Apple, thrown out of Apple, whatever. Was called Next. And basically when Apple realized they weren't going to be able to deliver on OS 9, they simply bought the whole company. And they didn't even bother to rename anything. So that's why you'll see NS everywhere. This was a replacement for the Copeland project. You can get into some fun Apple history here. But the fact is that what is OS 10 was never meant to be Mac. It was meant to be its own thing. And that's why it does things dramatically differently from all the OSs that came before it. I sort of mentioned this. The challenge of OS X is that it's Unix, except when it's Windows. And then a lot of times they're going to add OS 10 on top of it. So at the core, it's a monolithic monokernel. This gets into some computer science stuff I totally forgot. But it's a POSIX-compliant, BSD-derived operating system. Sorry? Is it a microkernel? Yeah, okay. Like I said, computer science stuff I forgot a long time ago. They've added a lot of Windows stuff on top of it to make it more friendly in Windows environments. And then they added a bunch of OS X stuff because Steve Jobs thought they should be there. So the number one thing you're going to run into when you're doing incident response on OS X isplists. Plists are everything. Plist is the data store of choice on OS X. It's essentially the replacement for a Windows registry on OS X. It stores configurations. It basically just can store anything. They refer to it as propertyless organized data into named values and lists of values using several core foundation types. CF, by the way, is an NS thing. It's core foundation. These types give you the means to produce data that is meaningfully structured, transportable, storable, accessible, and efficient as possible. That means nothing. And they've really stuck with that because plists can be almost anything. They can be flat text, they're mostly binary. They can also be XML or JSON. So this is a fairly common example of a plist. They're all over the place. And essentially, if you're building a tool that's going to do anything on OS X, the first thing it has to do is be able to handle plists sufficiently and aggressively. Mach-O is the binary type that OS X runs at its core. It's derived from Next. Like most Apple things, it's way too flexible to make people like us happy. So it works on 32-bit and 64-bit, PowerPC and Intel. Mostly, it's a little bit more of an advanced version of what a PE file looks like. It's got some things that came along a little bit later because it's not as old a data type as portable executable. So how do you get Mach-Os? You can get them in so many ways. They can come to you as packages, which are essentially like miniature file systems that just map directly onto your file system. If you're going to install anything that runs as root or runs with administrative privileges, it's mostly going to come to you as a package. You can do DMGs, or that generally just have apps in them. So a DMG, it's totally just a zip file. We're just going to call it something different because advertising. And then apps, which are actually just file directories. They just don't look like it. So if you're on an OS X machine, you can click on any app and go show package contents, and you'll realize it's just a directory structure. It just has an icon. You can get apps through the App Store. This usually isn't terribly important for incident response. So far, I might be jinxing myself, Apple's App Store security measures have been relatively good. They haven't had a lot sneak through that's been horribly concerning. And then OS X can run scripts. arbitrary, basically everything scripts, Python, Perl, Shell, Ruby, all that off the bat. You're also going to need to know about HFS, or excuse me, HFS Plus, which is the OSX file system. Unix-based, it mostly acts like Unix. Transparent encryption, per home directory encryption. They've added a lot of things to this. It's actually a fairly complicated as file systems go. And one thing I added that I thought was really important is that you'll come across a lot is XATTR, extended attributes. So an interesting thing OSX or the HFS can do is attach generic attributes to files that are anywhere on the operating system. This is especially useful for things that are in your downloads directory, because it turns out OSX tags everything in your downloads directory with where you got it from. Does anyone see where this could be useful for an incident response? All right. You'll need to know about kexts. Kexts are kernel extensions. This is how things run as root on OSX. There's these three little Apple tools that are built. This is essentially Apple's built-in security stuff. Gatekeeper is doing certificate signing and enforcement. MRT is their malware removal tool. XProtect is essentially their version of antivirus. It can look for hashes and a few other things. But it's pretty minimal. Given what they've had to deal with, it's been largely effective. So okay, that was a lot of lists and a lot of different concepts. We're going to get into one last one. So anybody who does malware, what's the one thing I haven't talked about as far as like major OS level stuff? I might have a sticker for you if you answer. ASLR. It does that. It's not terribly relevant from an incident response perspective. We haven't talked about persistence mechanisms. Where does malware has to keep restarting. And we get another hipster picture. I like this one. He's like a hobbit. So I've mentioned twice the whole, it's Windows, it's OS X except where it's Linux, except where it's Windows. This will be no more apparent than when you look at persistence mechanisms. So you can do cron jobs. You can literally just write a regular old Unix cron job. Isn't that great? Kexts can actually set themselves to run at startup. So someone can install a kext on your system. They get to just run at startup whenever they like. There's about 4 different places these can generally be per user account, so that gets a little complicated. There's launch daemons. Launch daemons is the OS X effective way of doing persistent restarts across things. Launch D is the first process that gets kicked off, and it's kind of a big deal. That runs anything it runs basically as system. You can do startup items, which are user specific. They're not privileged or anything, but they kick off by themselves. This one's deprecated, by the way. It just still works. There's a number of those. We also have login items. They're different from startup items. If you want to talk about that, we need a few minutes, but basically the same thing. It's the more appropriate way these days. We have login and logout hooks. And, oh, by the way, OS X is just nice enough, it'll reload any applications that were running when you shut the machine down. So I went through, that's 7. There are 9 more. No, we don't need to go through the rest of those. The point is, OS X is complicated. It wants to help you out by really allowing a lot of different things and having a lot of different ways of doing the same thing. And that becomes really challenging for folks like us, because you might go through the 9 more common places where malware could be persisting, and it literally might be the 16th one. So being prepared and automating things to cover all the different eventualities, and even just being aware of all the different eventualities, is a challenge on OS X. So the talk is about tools. I'd like to share with you some tools that I use in my day job that have helped me. I break these tools into a couple of different things. By the way, tools, and it's a hipster with a selfie stick. Oh, so good. I didn't look for a longboard. That's a good point. Opportunity. So I think about these tools into a couple different major sort of patterns. Alerting tools, which are to help find compromised hosts. Triage tools, which give you some extra information to determine is this a false positive or is it really compromised. Forensics of how are we going to understand what the attacker did on that system. Malware, how we deconstruct attacker tools. And then finally, reporting, which is how do we keep track of what happened, how do we make sure it doesn't happen again, kind of workflow stuff. So we got into some bit about the kernel, but the point is most Linux tools do work. So if you're used to doing this kind of stuff on Linux, you can generally go to your usual go-tos. Most of them are there. They'll mostly react the way you expect. Every so often, it'll be the BSD variant, which misses one flag or has one extra one, but mostly the same. A lot of what we end up using has been VMs, simply both for process isolation as well as being able to use any tool you want. If you're just I need my Ncase running on Windows 7, it's super easy to run Windows and get access to those tools, even allow those tools to have access to a file system. There are a couple built-in tools that make life a lot easier. It's not a single speed, but it's pretty good. The most common log source you're going to get to is var log. Everything in OSX is set to log into var log. If you only give me 30 seconds to do an incident response on a OSX machine, first thing I'm doing is just zipping var log and grabbing everything. System writes there. Applications are supposed to write there. I believe App Store applications are required to write there. This is going to be your go-to place where all system logs are going to be. OSX even gives you, I wasn't going to share everything that was going on with my system with you people. That one over there looks squirrely. Anyway, console provides a really nice way of looking through everything that's in var log. It does parsing, does searching. It's not as great as using something like Splunk maybe, but it's a good baseline tool to get started. Activity monitor, kind of a procmon-esque sort of thing that runs on the system. I really blacked that out pretty well, didn't I? Trust me, it shows stuff. Activity monitor gives you just a basic idea, running processes, what kicked the process off, all of those sorts of things. I mentioned XCODE and dtrace simply because they're developer tools, and developer tools end up being useful in a lot of cases. Debugging different things. Instruments is a nice, pretty front end for dtrace. Dtrace is a super powerful debugging setup. I keep thinking there's something there for using this for like hardcore incident response. I just haven't been able to take the time to figure it out yet. So if somebody wants to do that talk next year, that's a freebie. Enjoy. I mentioned Linux stuff, so your netstat, your LSOF. The three most underappreciated incident response tools, I think, OXED grep. So many things, because this is a Unix system, everything's files. And files mean pipe things around, move things across other tools, slice and dice as necessary. I have found myself getting deeper and deeper into all three of these. In kind of the same vein, Python, Ruby come by default. So does Perl, but just don't. Can we agree on that? Perl's hate speech. I'm sorry, who? Oh, well, then I guess I win. I'm sorry?
How much time you got?
Here's my simple take. Perl is a very large answer to a very small problem. I end up spending a lot of time actually though writing shell. For incident response, I think shell is also really underappreciated. It's an automation language. It's for taking stuff you do all the time on the command line and making it easy. I mean, isn't that half of what incident response ends up being most of the time, is just moving stuff through the same patterns on the command line? So those are all built-in tools. How about some non-security tools that are still going to be useful? Well, if you're on OS X and you're not using Homebrew and Cask, speaking of automation, these are really important. They give you access to a huge variety of tools that you don't have to figure out how to install or compile or whatever. It's just brew, install, blah. Super nice. Two of the first tools that I would think about doing that with are JQ and just Q. JQ bills itself as grep for JSON, very specific to JSON. And Q actually lets you write SQL syntax against CSV files. So being able to cat in a CSV file and then do select star from is really powerful. I end up using JQ in particular. So here's a JSON blob of stuff that came off of a tool that I'm going to talk about later. I can't read that and get much out of it, but I run it through JQ, and now it's nicely parsed, it's broken up, I can see what I get some syntax highlighting, and then I can actually even go through and then write syntax against that to simply just pull out the lines that are important to me. So this is a hugely powerful tool. It's super fast, so even if you're dealing with a huge amount of JSON, it's great. Apple Remote Desktop, for those times when you actually do need kind of the remote hands sort of thing. This is an Apple-supported tool. I think it actually costs a few bucks, but basically a more secure, more powerful sort of VNC to any Apple system. Some of my favorite open source tools that I think are going to be useful, and this is where we get into more of the security-centric stuff. Everything else has been kind of general. OSXCollector. Has anybody played with OSXCollector? If you're running a Mac, just download it. It's great. OSXCollector was a open source live response tool built by the team at Yelp. Specifically that guy, Ivan Lee. The only picture I could find of him on the internet is him threatening you with a knife. And if you get to know him, that really captures him. Great guy, really cool tool. They took a tool called OSXATTR that had been written by a gentleman in France called Jipe. They basically just built better engineering into it. It takes a system, just crushes through it, drops a huge JSON file, thus why I got really good at JQ, dealing with all that JSON, and then grabs all of everything in var log and gives you a zip file at the end of everything you need to generally diagnose what's going on with the system. Up until recently at GitHub, if we thought anything was wrong with the system, this was our first move, was just by default run OSXCollector and just have all of that there. It's a single Python file. It has no dependencies. It's actually something you can get someone to run with just a single shell script. It's great. Super basic. There's actually not a lot you can do with it. Or as far as messing around with it, it literally just wants to do what it wants to do. They included a ton of filters that you can go through the results afterwards, and it'll do things like grab every hash that comes through in the results and check them against virus total. And we're only going to tell you about the hashes that match against virus total. So the fact that there's not much here means this system was clean as far as we can tell. They support doing your own whitelist, blacklist, so if you have your own intelligence, you can kind of build that in. Super powerful, does everything you could want from a live response script. But eventually, you don't want to just keep running incident response scripts like that, because that's a one-off thing and it's fairly manual. So you need to step up. We just moved to this tool. It's called OSQUERY. That's Mike Arpaia. He's the guy behind it. This is an amazing wired, sketch of him that is embarrassing, and thus I like to put it in everything I do. So, Mike, if you're at home, enjoy. OSQUERY does a really cool thing. OSQUERY exposes your operating system as a series of SQLite tables. I initially didn't like this, but I've come around to it, because you can do things like select name from launch daemons where name equals foo. That allows you to do some really cool, really targeted stuff. So for instance, you can look for only launch agents that are not written by Apple. Or I want to look at any application in your applications directory that's name ends with XYZ. And it's allowed us to do some really targeted, really specific searches across our infrastructure and do so on a continuous basis. I said at the beginning how we're big on transparency, openness, and kind of working with our users. OSQuery is what's really allowed us to do that because we can share with them in a format that developers will understand. Here's what we're looking for on your system. Some little examples of using their kind of REPL system. So I'm doing select name and type and path from startup items. And it just kicks back, here are the 9 things that start as soon as I start my system up. I can also do name and size from kernel extensions where names not like com.apple, since that's how Apple names all of their kernel extensions. And I see that there's only 2 enabled, both of which are security tools I know about. So that's super powerful. It's really easy to get started with. There's a lot of other cool tools that have come out around it. One of Liam's coworkers released their remote management tool. GitHub built one along with Heroku called Windmill. Getting it set up is a lot of work, but it's a super useful tool once it's there. From a forensics perspective, has anybody heard of GER? Okay, anybody used GER? It's awesome, right? Yeah. So GER is a host forensics framework built by Google. It bears a lot of resemblance to one by another company, but that's backyard, or that's inside baseball. It's cross-platform, so it runs on OS X. It also runs on Windows and Linux, which is a super useful thing. It does memory forensics. It can pull in forensic artifacts from other places. It does super smart things like you can specify a file in a home directory, and it knows what the path to that home directory would be if it was Windows or OS X or whatever variety of Linux you're installed on. So that kind of stuff is really, really powerful. It's also got a really great API. So this is a tool that we use when we have an indication a host is compromised, and we use it to just be able to do a live forensic response. And because it was built by Google, they built it with the idea that it might be useful in the same data center you're in or across the world. So I've sat in Columbus, Ohio, using a server in DC to do forensic response on a system in San Francisco. Okay, that's the future. Like, that's super cool. Like, how are we not excited about that? It's pretty. It has a nice little UI. If you're doing memory analysis, because there are certain times where that is the only thing you can do, volatility is great even on OS X. This is a huge variety of OS X specific plugins they have, including things like parsing out p-lists and things, a number of OS X specific kind of tools. If you're doing malware, YARA, YARA is just the best for this by far. And doing searches for this across binaries in OS X works the exact same way as it would on Windows. We spent a lot of time using ELK, and while ELK is great on the server, it turns out it also runs fairly well on your own machine, especially if you're using Docker or something like that. Using this to grep through huge amounts of information is really nice. It's got, pretty graphs and things like that because managers. Fear, you don't just do all this stuff and forget about it, right? Right? You actually keep notes so you don't get compromised by the same thing multiple times. FIR is a tool that was written by CERT, Société Générale, and it does some cool things with entity extraction, stuff like that. I run it on my own machine just for keeping my own notes during investigations. We also run it as a server side for doing incident management. One last tool I just added that I just thought of was KNOCKKNOCK. This is Patrick Wardell, I think he's Synac on Twitter. And KNOCKKNOCK looks at all those different persistence mechanisms I mentioned and basically just bubbles them all up to you and makes sure you know they're there and they're what you're expecting. So you can look for cron jobs, you can look for kernel extensions, and then it even runs out and takes those hashes and submits them to VirusTotal just to make sure you're accidentally not running something malicious. So super good tool just to have laying around if you're paranoid. And all those were open source, which is pretty amazing. There's some paid security tools that I also use a lot of. This, by the way, oh, it didn't come out. It's actually a Santa Claus hipster. I'll show you later, it's great. PATERVA's MALTEGO. MALTEGO? I mean, stupefyingly cool indeed. It just does everything. We've used it as our main platform for doing a lot of incident response by building custom transforms to do a variety of things. Learn to write your own transforms. If there's one, people use MALTEGO and think, yeah, it's kind of cool, it does some neat stuff. And then you learn to make your own transforms, and it just changes the entire game. So, will this run? Okay, so this is me running a set of transforms I have specifically for GitHub data. And I'm going to go and get all the places I've logged in from. And someone's messaging me. Oh, yeah, okay, there's my public information from my GitHub account. And so building that kind of stuff in starts to make it super powerful because you can just pivot through information quickly. And it runs really well on OS X. So I actually wrote a blog post about how to build transforms for MALTEGO. I haven't talked a lot about malware analysis. The go-to tool for me on that is Hopper. I'm not a good enough malware engineer to need IDA Pro, so Hopper's a nice kind of middle ground. Does a lot of the same kind of disassembly stuff without costing more than my laptop does. Some other ones, and I like this hipster because he is just like telling people what is going on. He's very in charge. Sleuthkit and Autopsy for traditional dead disk forensics. Wireshark and TCP dump are go-tos. Hex editors. All right, so some final resources and some things that if you want to learn more are places I recommend going. Here are some very smart people who do OSX specific stuff. By the way, I'm going to post all these slides later, so if people just want to do that, that's cool too. Number of smart people who are doing very smart things around OSX. Here are 4 of my go-to sites that I always pay attention to because these are, again, similar smart people talking about OSX specific things. This book, OSX Incident Response, just came out. I'm glad I got this talk in before it came out because it's probably going to be way better. But I'm really excited for this book. I had it on pre-order. It is literally what I'm going to be doing this next week. As far as training, Sarah Edwards, SANS 4518, Mac Forensics is the go-to course. A number of different people have released information on hardening OSX. So DISA, there's a really cool tool released by GitHub called Santa that does whitelisting of applications, which is something that I don't think anybody else is doing on OSX. Some good talks on securing OSX and some tools. In conclusion, we talked about a bunch of core concepts like plist, Mako, HFS. If you're just getting started with incident response on OSX, I recommend starting with OSXCOLLECTOR, JQ, and FIR, which is that incident management tool. Once you get a little bit better, I recommend moving on to OSQUERY, GER, YARA, MALTEGO, and Hopper as necessary. But that first 3, the OSXCOLLECTOR, JQ, and FIR, are super powerful and will level your OSX incident response game up in a big way. I have to give the obligatory, I work at GitHub Security, and we're growing. We have some open recs for various security things if you're interested. And I appreciate it, and I'm happy to answer any questions.
For OSQUERY, do you have to run that locally, or is there a way to search across your entire environment?
So that's, okay, the question was, for OSQUERY, do you have to run it locally, or can you run it across your environment? The only part that they share is the endpoint agent. Now, the endpoint agent can be configured to run locally or to run remotely, but they don't provide a server in order to do so. There are a few different people who have. I'm one of them. I'm not in love with ours compared to some of the ones that have come out recently since. Marcin Wojciechowski, I can't remember, I cannot pronounce his last name, just released one called, I want to say it was called Glass Door, but I don't think that's correct, something Door. Dustin Mefix released one as well, and it's not hard to build your own, but it definitely supports the idea of running at scale. We're running it at scale. It works really well. Getting it to that point is a lot of effort.
Kind of building on that a little bit, is there a way to output that data to like a sim or something? Because if it's SQLite, how do you do that?
So the results it actually gives back don't come back as SQLite. They can come back in a variety of formats, JSON being the most common. Which means there's actually a configuration to go straight into Splunk or Elk or any of those types of things. If you have something that can ingest structured data, you're going to get structured data back from it. So we get the logs back, pipe them into our syslog infrastructure, and they get picked right up by our logging platform. So it's super easy at that point. And then you can do whatever makes the most sense for your organization with those. Anybody on the wings?
Yeah, you said you can run the OSQuery live.
Yeah.
Right? So do you have to create a baseline initially, and it builds on that baseline, like incrementally?
So the question was, if you run it live, do you need to baseline it? You don't need to.
Okay.
You could.
I mean, would you see a performance difference one way or the other?
I don't think you'd see a performance difference. And the other thing I'll say is that if one thing I probably should have put in there that is important is OS X is deceptive about its stability. So if you take 4 different people and get them all to hash a common thing like ls, if you have 4 people, chances are you're going to get 4 different hashes. There's not as much determinism as you'd necessarily expect across, for an operating system like that. So I would almost be afraid of getting too reliant on a baseline just because deviation could be killer. So, for a reason, because one of the things when we first were talking about this is, let's just hash everything in user bin.
Right, exactly.
Turns out, you get a ton of different things. So, and that's just live deploys and, continuous deployment sort of stuff on Apple's end. But it's complicated. So, baselining would be interesting. I haven't really played with that.
Just curious.
No, it's fair.
Did you mention that YARA recognizes all Linux distributions?
I'm sorry? Gert?
I'm not sure if I understood. You said that YARA recognizes all Linux.
All Unix.
Linux.
So GER has a project around it called Forensic Artifacts. And the idea of forensic artifacts is things like you want to reference a file or a home directory. Well, the home directory is going to be different in different operating systems. So in OS X, it's /user/username. In certain Linux, it's going to be /home/username. The thing that the forensic artifact tools does that merges into GER is the ability to say, I want to look for any files named X in a home directory, and it will understand that based on the type of system it's looking at, it might need to use a different home directory prefix to get there. So it's more just meant to kind of translate between different systems. And it's an open source project, and their coverage is pretty good, but I'm sure there's also opportunity to make it better. Ooh, we were talking about this one at lunch, and this is the fleet management problem on OS X is complicated. People have used Casper. I've not. I do security on it. I don't end up doing that aspect as much. most of what I've ended up doing has been letting the OS deploy as usual and then just simply having scripts that come through afterwards and change it to what I want it to be. But unfortunately, it's a little bit out of my scope.
Google's done a lot of work in that area. There's a pretty good talk. I couldn't tell you who presents it, but if you Google, like, or if you search for, Mac management at Google or something like that, you'll probably find the talk.
Yeah, and the Google Mac team has shared a lot of the stuff that they've built just live on GitHub. And I mean, that's where the Santa thing comes from. GERS out of that kind of thing as well. So you can definitely find a lot of useful tools for Macs built by Google on GitHub. All right, well, I'm around the rest of the day. Thank you so much. Really appreciate it.